Welcome to Communication Engineering playlist. Here in this session, I'll be going to explain amplitude modulation for calculation of transmitted power, efficiency of AM signal, as well as redundancy in AM signal. So this is what I'll be explaining in this session. So as if you see my previous session, I have already derived equation for AM signal, and that equation for AM signal was yt is equals to AC sin omega ct plus AC mu by 2 into cos of omega c plus omega mt plus AC mu by 2 into cos of omega c minus omega mt. Now here if you see this signal, so that is carrying carrier signal. So this signal AC sin omega ct, that is carrier signal. If you see this portion of signal, so that is AC mu by 2 cos of omega c plus omega mt, so that is carrying upper sideband signal. So this is carrying upper sideband, and this portion of signal that is having information regarding lower sideband. So this is lower sideband signal. So now in this session I'll be deriving transmitted power for this AM signal. Now ultimately total transmitted power, that will be power of carrier signal plus power of sideband signal. So if I say total transmitted power, then let us say total transmitted power, so that is PT, and that is based on this carrier signal. So when you calculate total transmitted power based on this carrier signal, so that will be square of the amplitude divided by 2. So that will be for carrier signal as well as for USB and LSB, upper sideband and lower sideband. So that total transmitted power, that will be power of carrier signal plus power of upper sideband plus power of lower sideband. Now I'll explain how to calculate power of carrier signal. So power of carrier signal, that is PC, and that is based on this signal. Now see, whenever you see any signal based on frequency component, like say here AC sin omega ct, where omega c is carrier frequency and AC is amplitude of carrier signal. So power of carrier signal, that will be square of this amplitude divided by 2. So that will be AC square by 2. Now what about power of USB and LSB? So power of USB, so that is based on this amplitude. So that power will be half of square of this amplitude. So if I say power of USB, so that is half of square of this amplitude, and that is AC mu by 2 and square of that. So if you calculate this, you will be finding it is 1 by 8 AC square mu square. And similarly for power of lower sideband, so that is having same amplitude, AC mu by 2. So that will be half of square of this amplitude. So power of lower sideband LSB, that is half of AC mu by 2 whole square, so that is 1 by 8 AC square mu square. Now see here sideband power, that is carrying information, carrier power is not carrying any information. So whenever you see transmitted power, that is addition of carrier power plus sideband power. In short, I can say this is what carrier power plus PS means sideband power. That PS is P of USB plus P of LSB. Power of USB plus power of LSB. Where this carrier power is redundancy. It is redundancy. Means it does not have information. So carrier power does not have information. And when you see sideband power, so it is having information. So sideband power, it has information. So ultimately, if I say what will be sideband power here, so sideband power PS, that is P of USB plus P of LSB. And if you add these two, you will be finding it will be same. So we can say it is 1 by 4 AC square mu square. So total power PT, that is PC plus PS. So total power now PT, that is PC plus PS. PC is AC square by 2 and PS is 1 by 4 AC square into mu square. So if you take AC square by 2 common, so that will be 1 plus mu square by 2. So it means this transmitted power PT, that is AC square by 2, that is carrier power. So if I place AC square by 2 is PC, carrier power, into 1 plus mu square by 2. So this is transmitted power. So first thing that we have derived, that is what transmitted power, that is PC plus PC into 1 plus mu square by 2. Now I'll explain you calculation of efficiency. So when we talk about calculation of efficiency, that is based on information. So what is efficiency? So efficiency, that is sideband power divided by total power. Efficiency is sideband power divided by total power. So what is sideband power here? So sideband power, that is PS. So that is 1 by 4 AC square mu square. So that is 1 by 4 AC square mu square. And total power, that is AC square by 2 into 1 plus mu square by 2. So you can say half of AC square into 1 plus mu square by 2, where mu is modulating index. So half of AC square by 2, that will get cancelled. So here there will be half again. And if you take LCM, so you will be finding this efficiency by after taking LCM, this half and this half LCM, that will get cancelled. So it will be mu square divided by 2 plus mu square. So efficiency, that is mu square divided by 2 plus mu square. So that will be efficiency of AM signal. Now third category, that is redundancy. Third is redundancy. So let us calculate redundancy. So to calculate redundancy, that is 1 minus efficiency. So 1 minus efficiency, that is mu square divided by 2 plus mu square. So if you take LCM, this will be 2 plus mu square minus mu square divided by 2 plus mu square. Mu square will get cancelled. So this redundancy will be 2 divided by 2 plus mu square. So this is redundancy in AM signal. So let us have a quick review again. When we talk about AM signal transmitted power, so AM signal transmitted power, that is PC into 1 plus mu square by 2, and sideband power, that will be 1 by 4 of AC square mu square, and in terms of carrier power, we can rederive this even sideband power by, if you place AC square by 2 as a PC, then you will be finding this will be PC into mu square by 2. The reason is AC square by 2, that is carrier power. So sideband power is PC into mu square by 2. That is even the basic equation that one can say. And efficiency of AM signal is mu square by 2 plus mu square, and the redundancy in AM signal, that is 2 divided by 2 plus mu square. Now see, these formulas are very much helpful to you to solve problems based on AM signal. So in next few sessions, you will be observing examples that I will be placing based on these equations. So that will be more clear to you to understand how to solve problems for amplitude modulation, for a calculation of transmitted power, efficiency and redundancy. Now see, next session I'll explain you amplitude modulation for multitone signal. So this is what the calculation which is there with single tone signal, but in next session I'll explain you AM for multitone signal. So stay tuned with this channel, give your valuable suggestions, give your feedbacks. Definitely I'll consider your feedback and I'll try to optimize all those things which is required to complete communication engineering here. So you can give me your suggestions regarding communication engineering. Definitely I'll try to sort out all those queries regarding communication engineering. So give me your suggestions. Thank you so much for watching this video.